All right. Good morning, good evening, good afternoon, wherever you're watching this. And thank you for joining
Hello, everyone.
on. Hi, Michael. Thank you for joining today. I hope everybody can hear Michael. We had sound issues last time we did this with this different setup, but I'm seeing a ping here on the audio meter, so everything should be fine. So
Yeah,
I'm looking
let us know
forward.
if you have any
Yeah,
issues as such.
exactly. Let us know in chat. Um, yeah, thank you for watching. We were back to the usual business when as I did last week, this sort of out of the normal episode, walking over or Twin4j newsletters. And this week I'm very happy to have Michael back at my side, where we can discuss AuraDB free together. So I'll give a
Welcome
quick
from quarantine land.
yes. Yeah, hope you you feel better, and yeah, your
Yeah,
quarantine will be lifted soon. Yeah.
that's. I hope so too. But still, it seems with all the rising cases in Germany, we need to do an episode on COVID tracing again because it seems to be this never-ending story, and with the crazy opening planning, it won't get better as well. I would have been at a conference actually this week, so because of COVID, I couldn't go to the conference, and I hope that all my friends at Javaland are still having a good time and don't get infected and stay safe. Yeah. So, yeah. So happy to be back with you, Alex, and having some fun today.
Yeah, looking forward to it. I think your audio is slightly delayed, so let me see if I can fix that. Quickly here in the settings. Or let us know in chat if it indeed is an issue. If no, then we can go forward with it, I think.
Yeah, let's just continue and
yeah, let's do that. All right, let me move over here and share my screen so I can quickly go over what's the plan for today. Little reminder before we do that, Graph Connect call for papers is still open. So if you are interested in presenting anything around graphs and whatever topic you are interested in covering, from June 6th to June 8th, Graph Connect is happening in Austin, Texas. So go on the website graphconnect.com and fill in the call for papers. We'd be excited to hear your story and have you live on stage to present to the graph community about whatever. Really, I mean, the topics are wide and far, really. So you can anything that's remotely connected to graphs, and obviously Neo4j is very welcome, and we're interested to hearing what you'd like to present. Yes, hands-on with AuraDB, the plan, what's going to happen. So quick recap of what is Neo4j AuraDB free. So that's this segment here. Then we're going to pick a data set. We're going to look at it. If you have a data set you'd like us to explore, obviously let us know. We can always have a stab at that. Ping us on Twitter or Discord, on the community forums. If you have anything, let us know. Then we think about what kind of questions we might ask from the data set we have picked, and what's kind of the model gonna look like, and with that model, what queries we're gonna run and explore that a little bit. Exactly, determine the data model, and then we load in query. So we have the data set into in AuraDB free, and we write some queries, give it a little spin, and then see where we end up with. Before we get going, what is Neo4j AuraDB free? So AuraDB free is the free version of Neo4j AuraDB, which is the graph database in the cloud, our offering that you can check out at neo4j.com/aura. It's the free version is free, obviously, so you get it. You don't have to pay for anything. You just need to register with an email address, and then you're ready to go. It's slightly limited from the big version, but not by much. The real limitation is only size. So 50,000 nodes and 175,000 relationships is what you get for the free version. But that is plenty if you want to play with some data, explore it, have a stab at it, try it maybe for the first time even. And you'll see, I mean, all these data sets we tried are well in these limitations, and you can do lots of it with that many nodes and relationships already. You have access to Neo4j Bloom in browser, so you'll see probably both of those today. If not Bloom, then definitely browser. It's free forever, so that means as long as you want it, you can have it, and we won't take it away. And here's the link to it. I'll post a link in chat in a second as well, so you can click there to find out more. And what's the topic today? European gas pipelines is what we have. So we look into that and explore. So Michael, anything to add?
No, happy to get started. So we'll actually look into a tool from a colleague of ours called Neo4j for building dashboards today. So instead of Bloom, we'll look at this because this allows us to do kind of a variety of different charts and maps and tables and other things with the graph data, which I think is a really useful tool if you're building applications on top of Neo4j, or if you want to quickly show the value of the data that's in the graph. So we're going to look at a little bit at this today as such.
Sounds good.
Cool. So if you...
Yes, people
do you have
should
my
be able...
screen
Yes.
on screen?
Yes.
Okay, cool. So sometime last week, a partner of ours, Graphileon, posted a tweet where they imported gas pipeline data into a graph and used that tool to visualize it. And I thought this is actually a good example of how you could use AuraDB free to get familiar with Neo4j. And it's a very current topic, as we all know, that dependency on fossil fuels is not something we want to continue and or actually want to reduce. And the sheer amount of gas pipeline is in Europe kind of really surprised me, and I thought this would be a good example data set to look at and to realize what's in there. So this is a screenshot from Graphileon. But also, if you just Google for gas pipelines Europe, there's a lot of charts and visualizations and other things as well. And actually, the data that he used was from the German Space Agency, from the DLR, who published a paper where they basically take the published PDF information from all these pipelines. I'm not sure if they had a screenshot in here somewhere. And they built a tool that actually parses all these PDF documents that are published and extracts the actual data out of these PDF documents, right? And then they have basically a tool that extracts that information and makes it available as such. And they have applied a lot of computer science to identify borders and pipelines and cities and georeferencing and all the other things from these PDF documents, which are kind of published in large numbers. But the oil and gas companies don't publish the raw data, but they only publish these kind of PDF documents, right? And that's kind of something that they did. And so they made this data available, and you can basically here from OpenMod, you can download the information, and it points to a Zenodo. And there you have lots of different data sets with this oil and gas, or this only gas pipelines, and pump stations and refineries and junctions and all the other things. And I downloaded one of those here, and you see that there's all kinds of data in there. So of course, some of it is also duplicate. So you have, for instance, something like compressor. So kind of where is kind of gas compressed again for the next section. You have consumers like refineries and things like that. So that's all this information about the consumers, what they're doing. Then there is LNG terminals. There is pipe segments, power plants, so gas plants, and production systems and so on. And so this is a lot of data, and it's probably too much to cover in this hour. So our colleague Niels, who also built this Neo4j dashboard, has put together a small set of pipeline data into an GitHub gist, which we can also share. Actually, I'll send it to you, Alex, and you can send it on here. And we will use this subset, and this is kind of a subset of the download data that you can get from here, from the gas pipeline data sets, right? So what I just showed you on my disk, but that's kind of too much, because you see that's kind of megabytes over megabytes of data, and that's probably too much for this session now. But for our purposes, this pipeline data set is good enough for us. So what do we have in here? We have for each pipeline an ID. We have the name of the pipeline, it's called source ID, which is kind of the same as, or similar to the ID here. And then we have the start and end of the pipeline, so the junctions of the pipeline that start and end this segment. The latitudes of the start and end, longitudes of start and end, the countries of the start and the end. And then a bunch of attributes, like how wide is this pipeline, how long is it meant to last, is this hydrogen gas, is this bidirectional, mean latitude, length is interesting, and also capacity, how many cubic meters per day, pressure, and so on. There's also some stuff like operators and so on. You also see this is output from a Python script, because they have just, instead of proper JSON, they put in here just none. So that's something that we need to fix when we'll import this. And then start here is also interesting, I think, as well. And
that's the year when the pipeline was built, I guess. Or
when
it
went into operation.
When in operation, yes.
I think.
Okay. Yeah.
When it started operating.
Why is that .0? Do you know? Is that a month or?
That's just export.
Okay.
Export issue. So they exported it all as floating point, even if it's integer numbers.
Yes. Okay.
Right. So, and this is what we're going to use. Unfortunately, in tags, there's nothing in this data set, and in method is basically just a description. What's interesting, they have an uncertainty for these parameters that we just looked at, but I'm going to ignore this for today. So that's something where you can say then, okay, the pressure is plus minus 10 bar or something like that, where the uncertainty is kind of covering the error margin of these numbers as such. But that's kind of the basic data set. As I showed you before, there's much more detail available here in all these files. So if you want to go deeper into what kind of consumers, what kinds of producers, what kinds of junctions, what kind of LNG terminals, and so on are there. So all the data is all there, so you can also get access to or download it and use it as well. Okay, and to start with, we'll pick an Aura database. So we'll go to Neo4j Aura. Alex, you already shared a link. And then we click on Create Database, and then we select AuraDB free. We give it a name, pipes or so, and select a region. So for me, it's Belgium is the closest, and say I want to have a blank database. And then I basically just click Create Database. And what's important is to store the password. So copy this password and keep it safe somewhere. And then you can see that it's setting it up, and it will take a few minutes, 2 to 3 minutes to set it up. So while we're waiting for this, I'm going to talk a little bit about like the data model, which is pretty straightforward, actually. Usually I would use the data importer tool, which you now can also use with Aura directly. So last time we looked at AuraDB, it was actually not integrated yet with Aura, but nowadays you can actually open the data importer directly from your Aura DB here. But because of this weird format that I just showed you, it doesn't work so well with data importer. We could still use it here if you wanted to kind of just do the model. Let me just clean this out here. And so what we have is actually pretty simple. So we have a junction, it's kind of a junction in the pipe. And between two junctions, there is a pipe. relationship, basically, right? So something like pipe here. Let me make this a little bigger. So, right, so, and this is where we map. The junction just gets the IDs and the geolocation and the country, and the pipe gets the other information, right? So actually, we could do this real quickly here. Let's see if we download the file from the gist, which we'll have here. You can just save this in downloads, pipelines. .txt or ts. No, it's not tsv. It's actually semicolon separated value. So I'm not actually 100% sure if actually the input tool will be able to use that. Let's see. No. So it doesn't like semicolons yet. So that's something that is still TBD. So we'll use this only for modeling right now. So we have the junction with the name and the ID and the latitude and longitude of the node, and then the pipeline with all the additional information. So we basically just write our input statement from hand. So Neo4j Aura, what we can do is we can open here Neo4j browser, and then with Neo4j browser we enter. So if I open Neo4j browser, let me do this here. If you open Neo4j browser, we also need the password that we saved before. So I'll just paste this in here. And then we can connect. And also for the dashboard, because I currently have the password in my clipboard, I just use this as well. So I just say new dashboard, yes, and I will paste the password here and copy the connection URL from here for my dashboard. So you go to neo-graphup.io, and this gives you this dashboard interface. I press connect, and then I can adding dashboards later after we imported the data. So before, or let's look at the data first. As I said before, this is in this GitHub gist that I just showed you, this one here, which we just looked at. And we can load this just with load CSV. Load CSV is a built-in command in Cypher, and if you say load CSV with headers, then it turns every row of the CSV into a map or dictionary, so we can use it later on. And we just tell it a field terminator semicolon, so it actually works with this. So we can just look at the first 5 rows, return row limit 5. So we just call each of those rows row, and we return the row and limit 5. And so we see, as I said, we have to get all this data. So we have, what do we have? We have the 2 IDs of the start and end node. We have the latitudes and longitudes of the start and end node, the countries up here. And we have the name of the pipeline. We have the ID of the pipeline. And then we have here in params, we have all these parameters that we looked at as such, right?
Mm-hmm.
So from that, we can actually now construct our query to create our data, right? What's a little bit tricky is that we have to turn these JSON structures into something. So these are just strings, basically, with these lists, right?
Yeah.
So we have to turn them into something that Cypher can work with. But fortunately, our Epoch utility library has some tools that can work with this. So what we can do now is basically we can take the different things that you're interested in. Let's start with the simple things like row.id as ID and row.name as name. So this is our name and our ID. The other thing that we want to have is Epoch convert from JSON list. I think it's row.country codes. Country code.
Mm-hmm.
Code. Countries. So let's see if this works. as row variable. Return ID name countries. So we see now we have our ID, our name, and our countries, and comma row. So we also need, because I need to sneak into what else do we need. So the other things that we need is the node IDs and the longitudes and latitudes for the start and end nodes, right? So we basically can copy this and just change country code to long as longitudes, lat as latitudes, and node ID as nodes. So this is kind of all the information for our start and end node. Every kind of 0 entry is the start node for each of these fields, and the first entry is the end node. And then we take the last thing that we need is our param thing here, right? And there it's actually not from JSON list, but from JSON map. Param, node param as params.
What's the difference between JSON list and JSON map?
If you look at these, here you see these kind of square brackets on each side of the. So that's a list. That's kind of a list of same value elements, basically, comma separated into an as a JSON list. JSON maps have curly braces and have a key and then a value and a key and a value and a key and a value. So that's kind of the difference between the two. And because from the string, so just giving it a string, it doesn't know if inside of the string it's a map or a list. That's why we need to tell it. And also because the return type of from JSON list is a list, and a return type from JSON map is a map. So that Cypher also knows what comes back from these functions, which kind of structure does it have.
Yeah, makes sense. Okay.
Okay, and if you run this, then it
gives you an error.
Yeah, an error because I removed
No,
rows now because we don't need this anymore. So,
Yeah.
but what we can just say return star. So, and now it complains about this norm that I mentioned about before, right? So because the norm that we see here, where they just have sometimes none in here without any quotes around it. Somewhere there was like here, operator none, right? So instead of having null or an empty string or something like that, it says none, which is the Python null value, to say so. So we just take this none and replace it with null, and then it's all good. So because none is a Python specific thing and not something that works in JSON. So we can do this here. We just say replace in a row param everything that's none with null, and null is a valid value basically in JSON, which means nothing or non-existent. So if we run this now we see kind of our countries, pipeline ID, our latitudes, longitudes, the name of the pipeline, the IDs of the nodes, and these parameters that we want to set on the pipeline itself. Right. So now that we got our data from the CSV with a little bit of work, we can now actually start creating our graph from this. Before I do this, I want to quickly do a constraint, create constraint on junction assert j.id is unique so that we don't create duplicate entries for the junction nodes as such. So, and it added this constraint. And now we can start adding our data. Because this file is actually not so long, so actually we can look at how big this is, return count star. It has 2,100 entries.
Okay.
But that also means that in Europe there are at least 2,100 pipe segments, because this is only a subset. So that's quite a lot of gas pipes going through Europe, right? So that's each of those is kind of one of these gigantic, however, 60 centimeter to a meter or 2 meter wide pipelines that go through the countryside, right? That's really crazy.
And that's all of Europe, right? This data.
I think this is a subset. It's not a full set, but it's a subset. These full sets are even bigger. I think the pipe segments. So you see, it's 11 megabytes of data.
Yeah. Okay.
So it's probably even more than this.
Yeah. Wow.
Crazy.
Yeah.
So we can do this now. So now we can actually say we create a node. And to make it idempotent so that we can run it time and again, we just use merge. This is our start node, which is a junction, and we merge on ID is nodes of 0. As I said before, the first entry in this nodes array is our ID for the start node. And then we say on create. When this node is created, we set this other information as well. So we have the country. Start.country is countries of 0. And then we also set start location is a point of latitude is latitudes of 0, and longitude is longitudes of 0. So that's kind of the location of the junction in the pipe, right? So where it connects to other pipes.
It is located, yeah. And we just to summarize. So we're taking this out of this list we had looked at earlier.
Yeah, so we can look at the list again. Let me just show this here. So this list has always 2 entries, right? One for the start and one for the end node. And so with index 0, we always get the start node entry for the ID, for the country, and for the latitude and longitude. And with index 1, we get the end node entry for ID, latitude, longitude, and country as well. Right. So that's how we get the information for the start and the end node as such. So this is our start node here. Actually, I can make this bigger. So this is our start node, and for the end node, I can just copy this and replace start with end and 0 with 1. That's basically end with 1, and then end of this. And then the other thing that we do is now we have our start and end node. It complains a little bit about that this will cause an eager operation because junction and junction are the same type of node, and if it does this kind of find and or create thing, then these things have to be isolated in the execution plan in the runtime. So it will do all start nodes first and all end nodes first, but it also means it will pull all data in for the start node first and then all data for the end node. And with large files, this can be a problem, but with our size of the file, it's not a problem. Just to explain why it does the underline thing here. So for large files, you can also just split this into 2 parsers where you do start nodes first and end nodes, and then the pipes in 3 parsers. But for our size, it's fine actually. So we have our pipe as connection between the start and the end node. So it points from the start to the end node, our pipe. And because there can be multiple pipes between 2 nodes, we also want to add the ID of the pipe in here as well. So it doesn't just check for the pipe between the start and end node, but it also checks for the ID so that we don't get multiple pipes folded into one entry. And then again, on create, we set the name of the pipe. And we set parameters pipe plus equals params. And the params will actually be set as individual attributes of pipe relationship. So like all these kind of diameter, length, start here, and so on will become, each of them will become an individual attribute of our pipe.
Okay.
With this syntax. So we basically can take this whole set of attributes and set it in one go onto an element, like a node or relationship.
Yeah. Okay. Mm-hmm.
And this type this time it's a relationship.
Okay. Mm-hmm.
And I think that's it. So we have the ID, we have the name, countries, latitude, longitudes, the nodes, and the parameters. So we got everything covered, right? ID, nodes, longitude, latitude, and for the pipeline, we set the name and the parameters. Okay, so if I run this, it takes a few seconds, so 1.5 seconds, and it creates 1,600 nodes and 38,000 properties on 2,100 relationships.
Mm-hmm.
So the number of properties is basically from all these parameters that are set on the pipelines.
Yeah, that's a bit
right?
long. I mean, usually maybe you tell me, but usually we see like a more of an even distribution across relationships and or nodes and
Yeah.
and properties. But in this case, we have lots of properties for the nodes.
No, for the relationships,
Or
actually.
for the relationships. Sorry, yes, for the relationships.
Right.
Yes, yeah.
So we also see this if you just look at those. So if I just click here on pipe, it shows me an overview. Here you also see that some of these nodes have multiple pipelines coming in and going out of these nodes as well. So we can actually look for this later on. But if you click on one of these pipelines, you see that there's a lot of properties, right? So diameter and here, ID, both directions, mean, latitude, longitude, capacity, pressure, and so on, right? So there's a lot of stuff on each of those pipelines. In the original data sets, there's the same amount of information on the nodes as well.
Mm-hmm.
So if you download this original data set, so this is more or less just the relationship data. So this is actually more like just the relationship data and not so much the node data. But in the original, if you download these, then you have all this information on the nodes as well, right? So for instance, for an LNG terminal, you have where is it, and you have all these parameters for the terminal as well. How much can it store? What can it work with, and so on. So if you load the full data set, then there's a lot of additional information on the nodes as well. So that's evened out. But on the other hand, in a pipe network, pipes are also an important element of the network, right? So they have a lot of attributes that you need to use there. Okay, what we can also do is we can actually, usually it would only show pipe as a type here. But what we can do is actually we can select, for instance, something like the name of the pipe. So we see also pipes flowing through here, right? So you see Eugal 21, Eugal 20, that's probably the segment number then, right? So it flows from one to the next piece as well, right? So, and it's actually in query that we can also do. The first query that I would like to do is kind of to see kind of which nodes have the most incoming or outgoing relationships here. So what I would like to do is to say, give me an start node, and for the start node, count how many outgoing relationships does it have, and then return the start node as such, and as degree, and we order it by degree descending. So we can actually return this directly and take the top, let's say the top 10. Right, so we take the start node and count how many outgoing pipe does it have as degree, and order it by this degree descending, and give us the 10 largest nodes. So they don't show right now the number of outgoing, but we see it in the table return here, right? So 6, 6, 6. So if I pick one of those and expand this, you see it has 6 outgoing. 1, 2, 3, 4, 5. There's one missing. Why is there one missing? That's interesting.
2, 3, 4, 5, 6. I count 6.
This one is incoming, right? Here,
Oh,
the
it's
arrow points
incoming.
into
I see. Incoming. Yeah, then well.
But it should actually only count outgoing. That's really interesting. Weird. But most of them should have like, or perhaps this was one with 5. That could be right? So this is one with 6 outgoing here, right? So that's probably like a terminal or something like this.
a
Right?
distribution thing.
Yeah,
could be it, right?
yeah,
Where it
exactly.
then splits off in like a distribution hub,
Yeah.
right? Where it's
Yeah, it could be like a port or like in something where
yeah,
it arrives in a country or something like that.
yeah,
And we can do the same for the other side. So if we want to see who has the most incoming, we just put the S on the other side, and then we see also 6 here. And if we expand some of these, we see actually these have all or mostly incoming, right? So here
yeah.
that's kind of a sink like a power station or
I don't know.
a
Maybe you need to zoom in a little
refinery or
bit
something.
so people can see it a little bit. But there's these little arrows that show
Yeah,
the
let me.
show incoming or yes, perfect.
Yeah,
Show
so
the
right,
incoming
so
or outgoing relationships. So here you see the arrow tip pointing into this LKDN7.
2012. Yeah,
Yeah.
exactly. So we don't have more information about this, so we would have to import the other data as well to get more information about these. But
Well, we
I
can look
wanted to look
where
more.
it is, right? I mean, we could basically copy the longitude and latitude
And see
value
where it
into
is. Yeah,
Google
that's
Maps.
true. Yeah, it's in Germany as well, right?
Yeah.
So and
Or it says
actually,
Germany, yes. Yeah. Yeah.
so we'll do this in a second with the dashboards. Actually,
Yeah.
the other thing that I wanted to see if we can follow a pipe, basically, where we say, okay, if follow pipes basically, and say, let's say we follow pipe for 10 hops as such. Because you have the name that is kind of the same starting point, right? So let's say this is our path,
Mhm.
and we want to express where all. So this is a little bit tricky because we have to compare 2 pipe segments, right? So one, the first, and then the second, and they have to share the beginning of the name as such, right? And these pipe segments always have an underscore in their name. So that's what we're gonna try to do. So this is a little bit more tricky. So we say all the pipe segments. So and we need to do pairs of pipe segments. So IDX in relationships. Oh, let's say let's make it a little bit easier. With path, comma relationships path as else and length of path as len. So what we want to do is we want to get a range from 0 to len -2. So get every segment up until the last one. And we say where rels of idx.name starts with has the same start as rels of idx +1, so kind of the next name, right?
Mhm.
But we need to basically take everything up to the first underscore because only the name up to the first underscore is kind of what I think the name of the pipeline. I think at least because the second looks like a segment.
Yes. Okay.
Right.
So
So I'm not sure if this
PS
how
is probably how the
pipeline is called. I mean,
pipeline
it's weird that they all called PS, right? So I'm not 100% sure if this works, but
yeah.
I hope at least for some it should actually work. Although I don't know, perhaps it's also not the case because these are like segments that are 1 to 3 between 2, right?
Mhm.
Yeah, let's see if something sensible is coming back. I mean, I just wanted to show you how you would do this. So you would
Yeah.
go over this kind of range of relationships, and then you would check the current relationship name starts with the fragment of the next relationships, the first fragment of the next relationship's name, right? And that must be true for all relationships of this path. And then if this is true for all relationships of the path, you return the path. So let's see if this returns something. It's probably a lot of data.
Yeah.
So it has to follow a ton. Like these 2000 relationships will turn up to 10, turn into like millions and millions of relationships, right? So let's try this with a shorter one, like perhaps 4 or 5 or so.
Yeah.
Okay, this doesn't like us right now. Okay, while it's doing this, okay. Let's see if I do like 4 or so. I'm not sure. Come on. 4. Oh, we should probably also limit.
Yeah, maybe return 1.
The problem is it returned 30,000 records. So I didn't limit it.
Okay. Yeah.
So it returned something, but it was too much for the browser actually to keep it. Let's see if we do this. Oh, here we see. And so this, and you can actually configure the browser to just return these paths. And here you see this 10p loop. Can you see that here? I can make it a little bit bigger.
Maybe let's scroll a little bit. Yeah.
Right. So you have 10p loop.
Yeah.
Here, 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 here. So it continues basically.
Yeah.
All the way.
Okay.
Up to 5 hops, right? Or here transcars 1, 2, 3, 4, 5, and so on, right? So
20.
Actually, what we could do is we could make this longer and return only one path, basically. But this is one of these 10 hop paths that we can see, basically then going from point to point to point. So actually what we can do in Junction, we can show country, and here we see actually how it goes from Germany, Czech Republic,
Slovenia, yeah.
And then actually let's see if it even goes further than this. I'm not sure. If we exceeded now the max length. Probably we exceeded the max length, and then it tries to needs to check all the other ones. If it doesn't find anything, then it has to go through all the rest, and then it might be too much. Actually.
Yeah.
Is there anything till 15? No. But you see the point, right? So there's here it's a 12. So that goes. Yeah, it just continues here.
Yeah.
And so that's kind of where you see one pipe based on the name, and you see these segments increment by 1 always, right? So that's kind of the segment number, the 13, 40, 15, and so on. Okay, so much for that in Neo4j itself. But what I wanted to show you is kind of this dashboard builder, which is really actually cool. So our colleague Niels built this, and if you go to our developer blog, you can also Neo-dash. So Niels also published a number of blog posts about this, how to use this, and it's pretty cool. So I'll send it to you, Alex. You can also share it with the others. 1 second here. Really nice tool, and it gets added more and more capabilities as such. So what you do is basically you build these dashboards, and these dashboards basically have certain things, right? So you can say what kind of data structure do I want to have? For instance, I want to have a table, and what size do I want to have? Let's say 6x3, and then I just return some data. So for instance, in our case, it's junctions and pipes. And what we could say is, let's call this S, P, and E. We could return the country of the start node and the country of the end node. And let's say the P, the length kilometer or something like that as this entry, right? So and if I save this, hopefully, it shows me these results, right? And then I can also sort by values and so on. So that's kind of a very simple way of getting a table here. But of course, we don't want to end at a table, so I'll just steal this query really quickly. What we actually want to do is we want to do a chart, like a bar chart.
Uh-huh.
And we also make it medium size, let's say like this. And then what I wanted to do is kind of to see as a source and end country, basically. I want to see how many pipes do they have? What's the sum of the length of the pipes?
Mhm.
And what's the sum of the capacity? The capacity had this really weird. It's called max cap
Ah,
cubic meter
yeah. Okay.
per day. So I can't remember this. I just call it capacity.
I wonder
And then
why.
I also wanted to have the what was the other attribute? The capacity, the length, and the count. I think that were the ones that I wanted to look at, right? So, and if I return this here as values in a bar chart, I can, oops, I can say I want to see, for instance, countries as
Ah.
the category, the start country, where
Uh-huh.
it starts,
Okay.
and then how many pipelines do they have? So, for instance, here in this data set, France has 79 as such, right? And we can also say what's the distribution of the length here as well, where the start country is here, or what's the capacity distribution as such, right?
Okay.
If
That's
we
cool.
switch countries here with end country, then we see, okay, that's kind of receiving countries.
Yeah. Okay.
Then that's where things are. For instance, this is capacity for Greece is
That's Greece. Yeah.
11,000 cubic meters, right? So
Yeah.
per day. And what you can also do is we can also say we only want to see pipes that actually cross country borders. So we can say where S dot country is not the same as E dot country, right? So
Mhm.
that's kind of only cross country pipes, basically, right? And then you see basically for recipient countries, for instance, Switzerland has a lot of capacity that goes in cross border, basically, right? Or the biggest length for source countries is from Norway,
From Norway,
actually, right? So
yeah. Makes sense.
Norway
Yeah,
as a producing.
they produce some.
Yeah.
Yeah.
So this is really interesting, and then you can play around with different types of charts and so on, right? So this is kind of gas pipeline charts. And the last one that I wanted to play around with is basically a map.
Ah, yeah, that's
Right,
what
so
we
you can
said.
also
Yeah.
choose map here.
Mhm.
And we want to make it a little bit bigger. Let's see, let's 4x3 or something like that. And our query here is pretty straightforward. It's basically similar to what we had over here, but we will return also the geolocations basically as such, right? So we would also return, we would just return the nodes. Actually, we can return the nodes as such, and Neo4j will automatically render it on the map, which is really nice.
Oh, okay.
Right?
That's super handy then.
So we just
So
we don't need to do anything
it
because
looks
we
into
already
the properties list and checks. Oh, there's a longitude latitude variable, and that's what it then.
exactly. So it
Okay,
also
cool.
says here a map will draw all nodes and relationships with spatial properties, and
Precision
because we have the
Oh,
because we have the location, we probably need to limit it because it's limited to like 1,000 entries or something like that, because otherwise the map gets too unwieldy.
yeah.
So and now we can see here already our map of pipelines, and we can here zoom in, and we see a subset of the pipelines here rendered on the map. Right?
Yeah.
So which is quite nice. And what we could now do is to deal with the limit thing is we could say we just want to have it within a country or something like that, right? Where we say where the start country is a country value and the end country is a certain country value. And we can pass this in as a parameter up here. So we can just country DE, for instance. And then we can actually return the limit because then it should be fine. And this would only render pipelines within Germany. And as you can see, it actually renders them here as pipelines within Germany. And you see that's
Wow.
right, all these. And then you can also select the label. So you, for instance, could say, I want to say the ID of this terminal or junction as the label. Or imagine you had other information like the city or something like that, right? So then you could, or the closest city, then you could actually connect this information
Yeah,
here, right?
you can show the capacity. Maybe that's interesting.
Yeah, but the capacity is on the
Capacity on the property, yes. On the relationships.
on a property.
Yes.
And actually, I'm not sure if you can. Let's try this. I'm not sure if you can sum the capacity basically. Gas pipeline map. I'm not sure if we return like sum of, but then
No, maybe not. Yeah.
Yeah, the problem is if we if I do collect P, so all the pipelines, and sum P dot, what was this capacity thing? As cap. I'm not sure if I can select this as an label. No.
No. Okay.
So it's only from the nodes itself, the label. Yeah. But still, I mean, we could just store it as a property, the incoming capacity. So actually, that's something that we could do, right? So we could just say, for our query here, we can just say, we can, we don't need the E junction. Well, it doesn't matter actually. We can just say set s.cap equals sum p dot max capacity per day, right? That's the income, the outgoing capacity from this junction, right?
Yep.
And actually, we need to do it like this with s comma cap. So and then we do the same for the outgoing one. So we just say it's the incoming capacity. And then now in our dashboard, is it here? We can actually go in, and we don't need this anymore because it's already on the attribute now.
Yeah.
And now we should be able to say cap, and then it shows us basically the capacity as an attribute here, which is a little bit unwieldy. We should have probably rounded it.
Yeah. Well,
right. But you get the idea.
We get the idea, exactly. Yeah. It's totally totally.
So we couldn't actually set it to round. Let me do this real quick here. Is it here? Round and its parts. Okay. And if you run our dashboard again, come on. Oops. Connect. So now you see that it's rounded values, so it's easier to handle. So we can also take another country, so which is probably not as big as Germany and doesn't have so many gas pipelines. Yeah. I mean, it also shows how many crazy pipelines Germany has, right? So which is really scary as well. For instance, this is the Netherlands. Let me just remove the label for the time being. But here you see like the terminals on the sea, basically, that take in.
Where they take in the
and then it's distributed basically across the country here. And it also follows like it's only on the here. It's also probably C terminals in Antwerp and
I'm pretty sure, yes.
In
Rotterdam,
Rotterdam,
Amsterdam
and
as well.
Then it goes all the way into the country here, as such, right? Yeah. So and we could do the same for the other countries as well, right? So you could see also kind of where is it coming from? So you can also say I want to see pipelines where it originates from this country, for instance, and where we don't see, say, so for instance, if you take Ukraine and say in this data set. Oh, there's not so much actually. It's probably because of the size of the data set that there are not so many.
Didn't you do starts in Ukraine, ends in Ukraine?
No, I just have.
Oh, you removed that.
I've
No,
removed
okay.
the.
Yeah, okay. Yeah.
Yeah, so it's probably because of the data set, so that it misses that
Yeah,
that
maybe
piece
it's not
because it's
complete.
not full ones.
Yeah.
But you get the idea, right? I'm
Maybe
not
to
sure how
Norway
it's
or
with
something.
Russia.
Norway
Yeah,
had it,
so but you see that it's here it misses some of the
yeah.
data. But it's also not the full data set as
No,
I said
of course.
before, right? So it's
Yeah.
only like 2,000 entries. But this is kind of how you can quickly generate a dashboard of data in Neo4j. And I
Super
really
easy.
love
Yeah.
the tool. Yeah, it's
Yeah.
super easy. You don't need to know a lot. It's basically straightforward to just get some data and return it, and then it basically renders it as a chart or table or bar chart.
Yeah.
You see there's a lot of, if you go in here, there's a lot of different types of stuff that you can get, pie charts, line charts, maps,
Very nice.
iframes. You can also have text segments with markdown as well, and so on, right?
Mhm.
And with parameter select, it's actually something that allows you to select parameters in the UI as well. So I haven't tried this myself yet. So we can say if you have a parameter select, and then these are available in all. So for instance, if I say node property and if I have a junction or something like that as label, and then it gives me the country, right? And then we can use this anywhere as such. So if I save this, I can pick Germany, and it then gives me, if I use this parameter here instead of my parameter,
Yeah.
then I can actually
And then you can
select.
Oh, that's cool. Yes. Yeah.
Then I can select like Poland here, and then it will change this in all charts,
In all
right?
charts,
So,
yes. In all. Yes,
right.
that's very good. Yeah.
So for instance, if I add here also the and s.country equals this, then this chart will also adjust itself by the. So for instance, if I take Belgium also, then it shows me Belgium here and Belgium here. So that's pretty neat.
That's very
Right.
neat.
So
Yes.
I can have the whole dashboard basically. So, and usually I would move this probably up here somewhere into probably a tiny one. And then I can move this basically, just drag this. I think I should be able to just drag it or something like that. So you would put it on the top left here, and then you could kind of select for the whole dashboard the values that are shown.
Yeah.
Right. So that's
Cool.
also something that's really useful as well.
It's now already a mini teaser of I'll do a Neo4j live with Niels in April. So we'll do a full session on this in a couple of weeks.
Yeah. So and Niels of course knows much more what you can do with this data and can demonstrate also way more detail than we've done here. But this is kind of what I wanted to show today, and feel free to do it yourself, try it out, see it works with AuraDB free, no problems, and we still are at a tiny section of our capacity here, even with this data. So it's not always the size of the data that matters. It's oftentimes just putting the data into a graph allows you to get much more insight and much more information from that than in other formats such.
Yeah. Cool.
Right.
We had before we wrap up, we had two questions. Do you think we have time to cover those?
Sure.
So let's go back in here. There was one asking, how can I tell Neo4j that I want the auto increment ID to start from a specific number? He apparently has a Postgres database that uses ID auto increment, and I plan to migrate that to Neo4j. Do you think that's something?
Yeah. So Neo4j doesn't have auto increment IDs. What Neo4j has as an ID is actually just an internal record number, and this always starts from 0, and you can't influence this how it changes. So what I would suggest is, so in a graph you also don't need these auto increment IDs to join things together, because you have the relationships that join nodes. And what I recommend is to usually use business IDs as keys into your entities, something like SSNs, or let's say email addresses, or ISBNs for books, or things like that give you a business key for that. These artificial IDs are actually not necessary in Neo4j to be used as such. So you can store the IDs from Postgres to refer them back to your original data. But the idea in Neo4j is not something that is meant to be used from a business perspective. So that's because that's just an internal pointer, and it can be reused. So you can have, if you delete nodes and later create new ones, they will share IDs with the ones that have been deleted, because it's just basically an index of a record on disk that is represented by these IDs. So from that perspective, use business IDs that represent something in your domain, not these auto increment IDs as such.
Cool. And the other question was, is Neo4j a good solution to store internal data, for example, assessment questions? I have different assessments with various modules and questions. The questions are also related to different levels. So that sounds like
that's actually a good use case. So there's a number of companies and projects that store assessment information in Neo4j. We even do it ourselves for our own Graph Academy, because your such an assessment is almost it's first like a tree. So you have something like a course, then you have modules, then you have each module has an assessment, and then in the assessment you have questions. But these questions are then related to kind of provided answer, then one of these or one or more of these answers is correct. So you want to represent this, which is still part of your tree. And then you have your students to take the quiz basically, and then you relate their answer back to the original answer. So you can also immediately see who answered correctly, what questions were more tricky for students, where did people have problems to succeed, do they cluster group somehow. Then you can also put these questions into categories or tags or other groupings, and you can relate them to each other, and so on. So it's actually a really nice way of representing assessment data. So there's also a number of blog posts. So if you just Google for Neo4j survey questions model or something like that, then there are a number of people that published articles about this. So for instance, here are two from last year. So building a questionnaire with Neo4j, and the other one is here, why you should store your survey data in a graph database. Right.
cool.
And so that's definitely something that's totally useful and valid to do this.
Yeah, absolutely.
Right.
Perfect. No, and if you, I mean, let us know if that works for you. Again, your community forums or Discord is a great place to reach out and to talk to the community. If you are struggling with anything, post it there. I think that brings us around to the end of today's session. Thank you very much, Michael, for showing us the data set and to getting us I think a good insight into the gas pipeline network across Europe. I for sure was not aware that it is that extensive.
Yeah, me neither. That is so crazy. So crazy. So many pipelines, right? And it will be an joint effort to get rid of fossil fuels and move to the future where we don't need this anymore.
Yeah, hopefully
so that's what I'm looking forward to.
Than later.
Yeah, and all the thanks goes to Niels for building these amazing tools and also preparing the data set as well. So thank you, Niels, for doing that. I'm really super excited. Yeah.
Cool. Thank you for watching. If you have any questions, usually you find us on Twitter, you find us on Discord, you find us on the community forums, or other places. Let us know what you like or to see in the future. If you like this episode, obviously give it a thumbs up. Follow and subscribe on YouTube or on Twitch if you want to be notified when we go live next time. We go live next time tomorrow. So if you are wondering when the next session is, it's a Neo4j live tomorrow with Graphileon. So you saw a little glimpse of Graphileon earlier when Michael shared the view. So we'll go into that. Tom from Graphileon actually will join me to talk about a route finding solution or application with Graphileon and Neo4j. Cool. So I'm looking forward to that tomorrow afternoon, Central European time. yeah, and with that, thank you all for watching. Thank you for joining us, and see you in the future soon, I hope. Take
Yeah.
care, everybody, and stay safe.
Take care, everyone.